Okay, what is that? Doing a little bit of testing on my circuit board. I've got most of the components soldered on there except for the little microcomputer. And sometimes I like to do tests on my pins before I put the microcomputer in there. So right now I have a 12-volt battery hooked up, my oscilloscope over there. So I got 12 volts jumpered onto the board, and then the first thing I do is check my voltages. Of course, that rail should be 12 volts, so it's the top of the scale on the scope there. See, and then I check pin 1 going to the microcontroller. See, it just goes at 6 volts half scale, so that's 5 volts right there. So, you know, and then I usually just go to some pins and make sure there's no cross connects, you know, for voltage, and there isn't. And then the next thing I started doing was I got these just set on 5 volts to jumper them. Looking at my little schematic, my notes, and then looking up here, you know, to see what traces to hit, I could just jumper like that relay, make sure the diodes are in the right polarity and all that stuff. And that one's the second one down. You can just barely hear it because that's a read relay. You just barely hear it clicking, but it one's cycling. This one here is 12 volts. It slams pretty hard, and I got a transistor that drives it from this pin here. And you actually, not that pin. One pin 18, plate reversing. So that's the third one down there. So you can hear that relay. And then this one right here, 1, 2, 3, 4, 5, goes to my plate servo. That's the MOSFET that drives that. There's a lot of power going to that with 12 volts, and I'm not pulse width modulating it, so it's pulling in when I put. So I put 5 volts to this pin, to the resistors, and then through the MOSFET. This is switching the 12 volts to that with the MOSFET. Now, looking on here, I got a plate reversing relay. That's that one I just jumpered a minute ago. 1, 2, 3. You can hear it click. Lock that on. Now when I put power to the MOSFET, it's going to move that arm the other way, the servo. See, now it goes out. See? Undo the reversing relay. It's going to pull in again. So, of course, I'm slamming it, not using pulse width modulation. That's what my chip will do. Because, I mean, I don't want to strip out the worm gear in this by slamming it. There's a lot of power. I mean, you can barely hold these screwdrivers with your hand. I mean, they rip when you put the power to them, man. So, yeah, I can't. I don't have enough hands to do it. But so in my processor here, which I'm getting ready to drop in there, it will use pulse width modulation, which is that dedicated pin out right here. That's the way I have it set up, plate servo. And the rest of the pins are just inputs. And if they're tied, shorted to plus or minus, it doesn't hurt the chip. So it's the outputs you want to make sure are not shorted before you put these suckers in there. And of course that the polarity is correct. So everything's working on the circuit. The test so far. So, oh, there's one more test. I need to put 12 volts to the feed that comes in and feeds this, and see if the Zener diode is set up right. So that should only be putting my schematic ignition pin 11 right here. So I could go ahead and put that right there. Need another jumper. There we go. I have to look up there. Which one is ignition? It is. Oh, it's this one. 1, 2, 3. Pin 3. Count it from the bottom. Pin 3 goes over, goes through the 100K resistor. There's the 100K resistor. That's for current limiting, and then the 4.7 volt Zener diode stuck in the way it is should take this 12 volts and limit it to 4.7. And you can see it's doing that. See, just a little under 5 volts, 4.7 volts. There's when the ignition key is going to switch on in the car, it could be anywhere from 12, 13 volts, 14 when the engine's running. So, and that's the voltage divider. That's going to drop it down to 4.7 volts, just for, you know, because these chips only take 0 to 5 volts for an input. Just converting it to that 5 volt logical input, so the chip knows that ignition is on. So, And then everything else that's connected to it is just inputs, you know, for buttons and whatnot. So it should be ready to plop that chip in. Okay, and I just dropped the microcontroller in there, microcomputer, whatever you want to call it, and give it a quick solder job. Oh, here's the one mistake I did make. I didn't leave a spot for the protection diode on this. So I just soldered right in there. It's under where the relay coil is. And stuff happens. I see professional boards where I see jumpers underneath stuff, you know, or a little, you know, part added like that. Okay. It's still fine, you know, it's right on the surface. Rest of it looks pretty good. Rigged this up. Obviously, it's not shorting anything because we just tested the operation of that. This is the 7805 voltage regulator. And that's an RFZ 44, I believe. Yep, 44 MOSFET. Those are badass. That's going to drive that's what drives that servo. That's what's going to flip the plate down so it can ignore Orwellian devices. So, man, it looks pretty good. It's got, you know, for heatsink, it's not touching anything, just lays in there perfect. I kind of got it hooked into the mount hole right there on that one screw. So this is going to tuck down underneath the dash. Powers all the plugs going to go into the wiring harness in the car, and then the plug on this side will plug over to a ribbon cable like this, you know. That will go to the LCD that will be up in that pod. So I'll give that several inches of ribbon cable. That way this board can be tucked down in there first, and then while the pod is lifted out of the way, and then it can just be dropped down in there. So this is looking good. I mean, this is a nice looking board right here. It's worth it. And then, of course, I got spares, you know. Got 2 spare boards. So, and I don't even have to use these for a backup. I mean, I probably will make one backup, or have the board to make a backup if anything happens. But I also could take these boards, you know, and very easily just reconfigure what the pins do. The relays are already hooked up to outputs. The inputs for I can make other projects out of these boards. Real easy. The LCDs already hooked up. Got analog inputs, digital inputs. Just reprogram the chip for what the input and outputs do. Bam, ready to go for another project. Very clean, you know. Do some other stuff with it. Make a motor speed controller out of one real easy, you know. Might be a little overkill for all the complexity, but all sorts of stuff. So anyway, yeah, it's definitely worth $50, $60 of shipping to get the 3 circuit boards made. I mean, I like the way these are real easy to solder to, and the solder comes out nice and clean. If I get it to focus, you know, it just comes out excellent. Look at that. It's just awesome. So looks like I'm pretty much good to go. Once I get the header pins, I'll go ahead and finish testing it with the input and outputs and be ready to put in the car.